Oh, if I said he, it'd be a freaking civil war in here.
Thank you.
No, but okay. No. Mr. Matt.
It.
Yes,
Mr. Matt.
King's mad.
Ah.
Mr. Matt.
Did you hear the 5:30?
Wow.
What do you have practice? Oh no, Matt said for something.
Matt just makes me angry. Mr. Matt.
This the stapler's James Charles.
That's
What?
aggressive. I appreciate
So-
your negativity.
Yeah, Mr. Mac, I'm kind of extra sad today, so.
Sorry.
Hey, man.
That really sucks. That's gonna make math really hard to learn. All
Okay,
right.
just because the stapler.
Here we go. So, AD is the bisector of CAB. So it cuts this angle into two equal pieces. That's what bisect means. Bi means two, sec means cut. Like second is a bra, right? Okay,
Isn't
it's
there
very
a
hard
lot
to
about
do.
angle, addition, postulate?
Yeah.
So, here's the deal. What we're going to prove is that AC relates to AB and CD relates to BD. Now, you notice that AC and CD are part of this triangle, right? And AB and BD are part of this triangle, but here's the issue. We don't have enough information to prove them similar. In fact, we have a conundrum upon us because AD is a shared side. Now, normally that's great. Shared side, it's great. The problem is that if these triangles are similar, then AD should relate to AD on both, right?
Yep.
And how does AD relate to AD? Well, AD divided by AD is
1.
1. They're the same thing, right? Which means that if AC and AB are related, like it says, they should also be related by 1, right? If the triangles are similar, then they're all going to relate the same way, right? By half, a quarter, whatever it is. And we know this is 1, right? So all these should be related by 1. Well, if they all relate by 1, then the triangles are congruent, right? You see what I'm saying? Here's two triangles, 3, 4, 5. If they relate by 1, right, that means one side is the same, right? 5 over 5 is 1. So that has to be a 3 and that has to be a 4, right? If they're similar triangles, they have to relate their sides. And if one relates by 1 to 1, right, then all of them do. And in this case, it's not just they're similar, they're congruent. Here's the problem. We only have 2 angles to get it done. And a shared side, so we have angle side, I suppose, right? But there's no other information. Now you might say, oh look, the triangle here shares that angle with the big triangle. Well, that's true, but we don't need to compare those two. We need to compare the two little ones. And even if I had that, notice that C is shared for this triangle, right? And the big triangle, but are the blue ones shared between the small and the big? No, there is no blue angle in the big triangle, ABC, right?
You can make it by a triangle.
So here's the deal. Nope, that's double blue. That won't work. But it needs to be exactly the same. Remember, if they're similar, they have the same angles, right? That'll be double the size.
Well-
So we don't have enough information to conclude that they're similar or that they're congruent. Now, we've had this situation happen before. You just know about it. So let me talk about something for a second. When we've been doing examples in here, they haven't just been random examples, right? I can throw 2 triangles on the page. Oh, look, they have 2 angles in common. They're similar. End the problem, right? Oh, look, they have 2 sides that are proportional and angle in between. Side angle side, none, end the problem, right? We're not doing that. We've been proving things that are actually useful. I will erase it if you can't handle it. Okay? So, what have we been doing? Well, this is what I want. No, it's not. This is what I want. We've been proving things like this. Remember when we did number 5? This is an actual theorem. It says that if you connect the midpoints of a triangle all up, you create another triangle on the inside. And this will always be half of this, right?
Yeah.
We proved that, right? This is double that. That's what that says. And not only that, but the opposite sides will be parallel, so these 2 sides are parallel. If I rotate the diagram, same thing. Double, half, both are parallel, right? And I keep doing that for all the sides. So we proved that. We also proved this monstrosity, right? Remember that? And we proved that this right here, if you connect the vertex to the midpoint and a vertex to a midpoint, they intersect here. And that intersection breaks up these segments into half and double. So if that's 2, that's 4. And if that's 3, that would be 6, right? We proved that. And again, you might not remember the details of that 100%, but we did. These are theorems. So that whenever you see a triangle that's like that, you can say, oh, look, half and double, right? If that's 10, then that's 20. Oh, look, midpoint's all connected. That means these are parallel, and that's half of this, right? These are theorems we can later use, and we're going to learn about them next week. One of the theorems that we proved, we did know about already. And that theorem is Pythagorean theorem. Now, if you're going to prove Pythag, you start with something like this, right? And you're going to prove that a squared plus b squared equals c squared. Now, the problem with this is that we want to prove that the parts relate. So we need to prove congruent triangles or similar triangles or something, right? But here's the problem. How many triangles do you see here? One. So what are we going to prove congruent to what? What are we going to prove similar to what? We couldn't do it. So what they did is they added in another line, and now we've got other triangles, and that's how we solved it right now. They added in line for us. But that's how you go about it. Now I've got more triangles, now I can say something about it, right? So when we couldn't say something, we added more triangles, right? We only want to save that for last resort because adding more triangles to our problem complicates it, right? But sometimes, when there's nothing else to do, you got to add in more triangles. Now I know that these can't be proven similar. I don't have enough information. And I know even with the big one, that's not going to help us with these guys. And that shared side complicates things because if they are similar, then they're actually congruent, right? So it turns out we just don't have enough to get it done, and they're not going to be similar or congruent. We need something else here. Yeah,
Could you extend the line A and D?
we're going to do something like that.
Okay.
So here's the deal. Okay, I'll show you what we're going to do. Okay, it's weird. It's a big brain play, so I'm going to show you. I would not expect you to come up with this on your own, although you're kind of close. Okay, hold on. Is it a suggestion?
Well,
Because I'm not looking for suggestions just
isn't
yet.
AD perpendicular to BC?
Now we don't know. That doesn't say 90, right? We know that those two angles add up to 90, and if they were both the same angle, then they must be, right? Or both of them add up to 180, right? And if both were the same angle, then, divided by 2, they must be 90. But we don't know that they're the same. They just look like they are, okay? Good question. So, how do we solve a problem like this? Well, let's think about what it's saying. It's saying that AD is the bisector of DDC. Cool. So if you have a triangle, and you have a line that cuts an angle in half, apparently, this side and these two sides will be proportional, and these two will be. Now notice they didn't say this would be, right? So what they're saying is that we have a situation like this, where I have two triangles, and two sets of sides are proportional, right? What's the proportion here that I chose? Double, right? Half, depending on how you look at it. But we don't know about the third side. Is there enough information here to say the triangles are similar?
No.
No, we only have two sides, right? We have no other information.
They share line A.
It could be that this is 5 and then this ends up being 5, right? Would they be similar? No. So what they're saying is for any triangle, if you divide up its angle, you'll create two triangles that are like mostly similar, but the other side doesn't have to be necessarily. And that's what that says. So these triangles we're not going to prove similar. We're not going to prove congruent.
We're just
We
gonna
need
say-
to do something else. Okay?
What else?
So here's what we're going to do.
No.
Now, remember we're allowed to make it perpendicular whenever we want, right? We're allowed to do that because there's always going to be a way to make a perpendicular line, right? If I draw you a line, can you make a line that's perpendicular to it? Sure, you can get a protractor and do it, or we could just eyeball it. But perpendicular, so it says me. That's actually not too bad, right? So if we can make perpendicular lines at will, if I give you another line, can you make a line parallel to that?
Yeah.
Yeah, sure. I mean, you could get out a protractor and do it, or we could just say, look, pretend I did. That's parallel, okay? More or less. Let's pretend it is. So not only can we create perpendiculars, we can create parallels. And why parallels are useful is because parallels get us cap, and cap gets us a lot of angles, right? Vertical angles, all kinds of crazy stuff. And if I have angles, can I prove things similar, right? I only need two angles. So parallel lines, adding a parallel line somewhere in here to an already existing line will be a good way to go about getting some more angles. And that's what I need, because I only have one, right? So here's what I'm going to do. I'm going to draw a line from B that's perpendicular to DA. Ready? Mostly perpendicular.
Are we making like? Oh.
So I'm going to say, let there be, and I'm going to zoom out so you can see what I'm saying.
No.
You know what we should call this line? We're going to call it BE. You know why I'm going to call it BE?
B.
Let
There.
BE.
Oh!
Let there be. Get it.
What's wrong?
Okay.
Wow.
It's
You're
cute.
funny.
It can be one thing, guys. It's not smart. It's not. It's be cute. Always. It's the best thing you
I
can
think
do.
I've got
We're
that
making
one.
just.
I know, right?
We're making a triangle.
Here I am being a math teacher. The worst.
You
All right, so
signed up for
No, my
this.
stepmom's come with you for a while.
we're going to say these are parallel. So says me.
Oh,
We can do that, right? We can create a parallel line wherever we want. So those are parallel. I'm also going to extend this side. And when I do that, let me get out where's Saddam? Here it is. Let's take out Saddam. All right, here we go.
I don't have Saddam. Why do you call it Saddam?
It's a joke about dictators because I said take out the ruler, we need a name for it, and then the thing happened like a couple weeks ago. Yep, America, right? It was a joke, it was a satire saying our country is dumb and we shouldn't do these things because it disrupts things that we don't know what to do, right? And then it happened again. Okay, so we're going to extend this line. Let's call it X for intersection. I don't know. So we're going to say let there be BE parallel to DA, right? Okay, parallel to DA. And let's extend CAX. So what we're going to do is we're going to say let CAX exist and BXE.
I am like blind and don't understand.
I'm going to zoom in for in a second, okay? So what I did is I created this parallel, yeah?
Where?
Yeah.
There's an A here. And a B here that I need to rewrite for later. Okay, cool. So I've got CAX, I extended that, and I extended this guy to be parallel, BE parallel to DA. Now notice they both have an X in them, right? So those two line segments share that point. Does that make sense? Right? CAX and BXE, they must intersect at X, right? So that's my construction. Yeah.
Could, on the X, could those be vertical?
They could be vertical. Again, lots of things are helpful, but not everything's going to be useful.
So it might not be useful.
Right? Exactly. Vertical angles is the epitome of true, but may not be helpful. There's vertical angles everywhere. Same thing with linear pair, like those two add up to 180, and these two add up to 180, right?
Well, thanks, Captain.
They're everywhere, right? Exactly. Wait until you know you need them. That's my advice on vertical angles in LPT, okay? So, do you see how I've constructed that? I made a parallel line here, and then I extended this guy and made them intersect. How do I know those intersect if I just looked at the directions? Because they both have an X in them, so they must intersect at X, right? They both have X. Right? Does that make sense? Okay, so I've created that. Now, why did I do that, and what did we get? I'm going to turn this, and I think you'll see it a little bit better. We have a very large triangle now. And notice that the top triangle will be similar to the big triangle. Why? Well, notice the top triangle here has this blue angle. Parallel lines cut by a transversal. Why are these two congruent? By cap. Those two are the same, right?
Can we just draw it? You know, like, out, like,
What do you mean?
I don't, because it seems like you're just like, someone just like, okay,
Making
let's
stuff
just
up.
do this line and then boom.
How did they come up with it?
Yeah.
Big brain play. I would not expect you to come up with this on your own. But once you see it, right, I want you to be able to see it.
Is it on the test?
Wait, you just said that we won't have to come up with it on our own, but now it's on the test.
Hold on. I'm not going to give you a problem you've never seen before and have to be like, oh, big brain play, we got to draw perpendicular or parallel here. No. I'm saying once I've shown it to you for this specific problem and this one only, I want you to be able to draw it a parallel, okay? You'll know that that's what we need to do. It'll be okay. We're not going to do the, right now, I don't think we're going to do this one on the quiz on Thursday. I think we're going to save it for next quiz. However, it's potential.
It will be there.
I also have good news for you. Number 4 will also not be on the quiz this week.
What's number 4?
Number 4 was that god awful one.
That was terrible.
Right, it won't. We're going to use that next week too, so I'm going to give you another week to digest, and it'll be on that quiz, okay? So, here we go.
Are we reviewing tomorrow? Too?
Yes,
Yeah.
so these two are congruent by cap, so I'm going to write that. Angle CAD congruent to angle CXB. Again, this is really just, I want you to follow my logic here. We'll go over it again, right? We'll back up and go over it again. But I want you to follow my logic. Does everybody see that those are cap? Two parallels cut by a transversal. So those are cap. Right. Two parallels. Isn't AB also a transversal? So I could extend that out, and I'd have a corresponding angle down here somewhere, right? And that would be vertical with this angle. I'm not going to do that because it's a lot of writing, right? To go cap and then vertical. I'm tired of doing that. We talked about that a couple days ago, maybe yesterday. The shortcut for that is alternate interior angles theorem, right? Where you do cap and then vertical, right? If you don't feel comfortable with alternate interior, do cap and vertical, right? Extend your lines, do cap, and then do vertical, right? But I'm going to say these are alternate interior angles. How do I know? They're interior because if you take the two parallel lines, they're inside the parallel lines, right? This angle and this angle, right? They're inside the parallels. And they're on alternate sides of the transversal. See how that one's on the right side of the transversal and that one's on the left side? So they're alternate and interior, so they should be congruent. So by alternate interior angles theorem, those are congruent. And this was by Cap, right? By alternate interior angles theorem. Angle DAB, don't you dare, congruent to angle ABX.
Wait, what's that? Like theorem thing? Like that.
Alternate interior angles.
Okay.
Right? Good question, Jenna. All right. Now I'm going to pause. I'm going to turn it. I'm going to ask you, what do you see?
3 triangles.
Isosceles.
Well, there's more than 3, but yes. Isosceles triangle. Right? Where do you see, what's the isosceles triangle? Someone on the Rosie, she sees it. Where's the isosceles triangle? AXB. How do we know it's isosceles? By the converse, because we have the 2 angles, right?
See.
Cool. So what do we know about AX and AB?
Isosceles.
They're isosceles, right? They're congruent. So that's congruent to that, right? Opposite sides should be congruent.
Ever like wanted to do geometry? Like,
I know, right? Oh, I love it. I used to hate
Why?
it. I used to hate it. I was like, please, dear God, don't let me have to teach it someday. And
Well,
then I
then-
learned how to teach it. And I love it. It's the foundation for really everything.
Why do you?
I don't think most math teachers have an appreciation for it, though. I think most don't know how to teach it, and they just BS their way through it. You guys are learning some real geometry, though. No pun intended, but you guys could run circles around other geometry classes. Really could. You really could. All right. Great, but so what, right? Well, last thing. I'm going to say that these 2 triangles, the top triangle and the big triangle, are similar. Now I need 2 angles to do it. Well, the top triangle has a blue angle, and the bottom triangle has a blue angle, right? The big triangle. That one doesn't count because it's not the whole thing, right? So I need 1 more angle. Do you see it? What's the last angle that's going to be between this guy and the whole thing? Go!
Is it angle C? Ha!
It's shared. Classic top angle being shared, right? We've been doing that in a lot of diagrams. Notice that C is the top angle in this triangle, and it's also the top angle in the big triangle, right? It's a shared angle. It's literally the same angle for both, right? So by shared angle, angle C is congruent to angle C. And now that we have 2 sets of angles, let me zoom out. Now that we have 2 sets of angles, we can say the triangles are similar, right? By AA. So again, if you didn't see it, little triangle has a purple and a blue. Big triangle has a purple and a blue. Again, that doesn't count because it's not the whole thing, right? So by angle, they're the same. Or similar, I should say. I'm going to say that now. By angle, similarity, the top triangle, I'll call ACD to keep alphabetical, is congruent to the other, or not congruent, is similar to the other triangle. All right. A is my first letter that I wrote. It's the blue angle in the small triangle, right? What's the blue angle in our big triangle?
X.
X. Did everybody see that? So A and X are going to go together, so I write X next. C is my next letter. C in the small triangle is the purple angle. What's our purple angle in the big triangle?
C.
Also C, right? They share it, right? And then lastly, we have D, which is this unknown angle. What's our unknown angle in our big triangle? B, right? This big thing down here. Now, it turns out, by CSP, those will be the same angle. Or by cap, right? Because they're 2 parallels, right? Cut by a transversal. But I don't care about that, so I'm not going to write it. Again, true but not useful. What I care about are sides at the end of the day, right? Okay? So I'm not going to write it, but I do know that B goes with D. So now I'm here. Cool. All right, so Jenna, do you need me to zoom out? or-
Yeah.
Yeah, okay.
thanks.
Right. So,
How can you see that? I don't understand.
bigger letters?
I can't even read it.
Oh, no, like, even your writing on the freaking side.
I'm sorry.
Well, it does blue.
There you go.
Unfortunately, the extension here made the triangle really big, and so I added, you see what I'm saying? I'm sorry about that. I wanted plenty of room to show stuff in the diagram, though, which I really could have minimized now thought about it, because we're actually not going to write that much more on this diagram. We're pretty much done. So, it turns out little triangle is similar to the big triangle that we made, right? So let's match up their parts, because we want to know about parts, right? So we know by CSP, AC should relate to what on the other triangle? Look at the letters. I'll zoom in so you can see.
X.
XC, right? CD should relate to
C.
CD. And AD should go with XB. Does everybody see how I got those first and third here, right? The letters match up. They're corresponding, right? They're in the same relative spot. First and third for these guys, second and third for these guys, first and second for these guys, right? Now, here's the problem. We want to know about AC and AD. Well, here's AC. I don't see any ABs. We want to know about CD and BD. Well, there's CD. I don't see any BD. And here's why. If you look at our diagram, we've got AC and XC, right? We have the piece and the whole thing. What we really want is AC and AB, right? Yeah. We also want CD and BD, but we have CD and CB. So we have the piece and the whole thing, right? That's what we got, right? What we want are the two pieces. Now, luckily, AX is the same thing as AD, right? So they're interchangeable, right? So we can get these guys together eventually. Here's what I'm going to do. I'm going to do segment addition postulate. I don't want XC, right? I want AB. But don't you notice that XC is made up of AC and AB? I'm sorry, AC and AX. And AX is the same thing as AB. So here's what I'm going to write. I'm going to write, instead of writing XC on the bottom of this, I'm going to write CA plus AX. You guys see how that makes up the whole thing? I'll say it again. On the bottom of here is XC, right? What two segments make up XC? CA and AX, right? So those two added together should be the same thing, right? So I'm going to write bi-segment addition postulate. XC equals AC plus AX, right? Now, I don't want CB, right? I want CD and BD. So I need to get rid of that. CB. Well, isn't CB made up of two segments? What segments is CB made up of?
CD, BD.
So CD plus BD should add up, right? So CB equals CD plus BD. Cool. By substitution, don't need to write it. We can just do it. Okay, that's first semester crap. Instead of writing XC, can't I just write these two underneath here? Right? Instead of writing XC, I can just put that underneath there, right? They're the same. Instead of writing CB, I can write that underneath there. So here we go. I'm going to write AC over AC plus AX equals CD over CD plus BD. Where did I get those from? This is all the same, so I switched them out. Cool? XC is AC plus AX, so I switched out AC for AC plus AX. CB is CD plus BD. So instead of writing CB, I wrote CD plus BD, right? You see how I got that? Okay. Here's the problem. I want AC over AB. I don't even have an AB down here. I want CD over BD. Oh, at least I have a BD here. But didn't we say AX and AB are the same thing?
Yep.
So I'm going to switch out AX for AB. I'm just going to cross it out. By substitution. They're the same, right? Cool with that? Okay. Here's the problem. We have tag-alongs. Right? We need to get rid of AC and CD, and then we win, right? If we had this, we win! How do you solve a problem like Maria? So we're going to take a break for a second, and then we're going to talk algebra. Okay. So take a quick break so we can drink and eat it. Yep, go ahead. Now's the time to do it. We get 2 minutes. Go. Taking a break is not an option. You have to. You're going to need it. So whatever you need to do to take a break, do that. Okay?
How much sulfur?
I'd play a song of the day right now, but now that we're live, it'll flag my video and take number YouTube. It used to be they'd be like, you can't monetize that, and I'd be like, joke's on you, I'm not monetizing it. Because I'm not a capitalist, although they should. But now they're just taking it down right away, which kind of sucks. Doing it for free, who cares? Right? I'm sure Bob Dylan would not mind that I used his song. last time.
Are you implying that we're sharing a straw?
Yeah, we're all drinking out of the same thing. We're all going to get sick. It kind of defeats the purpose of the hand sanitizer. We need more straws.
You've got a point. Coronavirus is better with Lyme disease.
Is better with Lyme disease? Are you talking about like
Because a cold
like-
corona
like
can't go better without a Lyme.
That was good. That was good. That was good.
Because he has them.
I got you.
I can't believe somebody actually put I get body
Just
shamed.
because I'm gonna die in 2 years doesn't mean you have to make fun of me.
It's okay, Gabe. Right. Real talk for a second.
I'm happy to die.
Not that you guys are doing this because you're not, but a lot of people are using the coronavirus to be really racist towards people. So let's make sure not to. You are.
Ooh,
I'm just
I'm
saying.
making fun of
I'm just saying real talk.
What they
Yeah,
make it
Gabe was
racist?
making fun of me.
Oh,
Real talk.
never mind.
I'm
Real
making
talk.
fun of myself.
No, you were fine. You didn't do anything wrong. I just wanted to use the opportunity to bring that up.
It's just a virus.
Yeah, not
You didn't know
No,
that?
I just forgot.
What?
All right, as soon as Elizabeth gets back, we'll get into it. So our problem is how do we get rid of AC and CD in the bottom? Because if we can do that, we win, right? So it's algebra time.
Right.
And again, I'm not starting yet.
Multiply.
Let's talk about what we might try. Those are both ideas we're going to talk about. Turns out neither of them will work, but I'll show you why they don't, okay? Again, if you had me for algebra, you'd know, but you don't. And so I kind of have to do this segue, and I'm sorry. You're going to be okay. I'm not starting yet. Make sure you enjoy your break.
Hurry.
I'm really dizzy. You're giving Rosie hot flashes.
Hot flashes. I'm not.
Where's your Mac?
Yes?
I'm dying.
Sorry, Mace.
Well, I was gonna say
It's because
something and I
Chelsea.
forgot.
It's Chelsea's fault.
Okay.
Chelsea's still only hot fresh.
This is where we left off.
Mac, do you have
I'm
a
gonna
knife?
like get hit by a car. I'm gonna be like in
Me and
another
Kate
car.
are gonna be
It's
going
gonna be like Chelsea.
Gotcha. I support this. I don't have a knife.
So I can get Lyme disease, so I'm halfway to that.
That makes sense. All right.
I'm gonna be like 90 years old dying of natural causes.
All right, so here's our problem. Now that Kozin's back, here's the problem. We need to eliminate both of these so we win, right? The question is, how do we do that, right? What do we do algebraically? Now, if you're not sure how to work with variables, and that's what these are, right? AC is some length, CD is some length, right? What you should try to do is stuff with numbers, okay? So let's play around with this. Remember, they are equal, so we can't just plug in anything. They have to be equal when we're done with it, right? So let's make AC, I don't know, how about 3, right? And let's say AC is, since it's 3, it's got to be 3 here. And let's make this
6.
Let's make it 2. AB 2. Okay? Cool. Fair enough. All checks out. Now, what does this simplify to?
3/5.
3 over 5. So whatever this is should be 3 over 5 and we're done with it too. Again, we're experimenting with numbers so we can figure out how to move this around. Okay? So let's make this something. I need a fraction that's equivalent to 3/5. Give me a fraction that's equivalent to 3/5.
6 times.
6/10 works, right?
Yeah.
So let's put 6 on the top, right?
Yeah.
And then that means CD 6. And so what does BD have to be 6/10? 4. Now again, 6 over 10 is the same thing as 3 over 5, right? So it's a true statement. Good. So we're starting out with something true. We're going to mess with this and see what we can do to get rid of this stuff. So you suggested subtraction, right? Subtracting 3. If I try to subtract 3 from this, here's what happens, right? I've got 3 over 3 plus 2, and I'm trying to subtract 3. I need common denominator, right? I put 3 plus 2 on the bottom. So I have to, and how did I get there? I multiplied by 3 plus 2, right? Does that make sense? There's a 1 on the bottom here. So I multiplied by 3 plus 2, so I have to multiply by 3 plus 2 on the top. That becomes 9 and 6. Distribution, 3 plus 2, right? Okay, trust me on that. Right? And so what happens is I get this. Common denominator, 3 plus 2. 3 minus 9 minus 6. 3 minus 9 is negative 6. Negative 6 minus 6 is negative 12. We get that. Does it go away? That's my point. No, it's still there, right? Subtraction isn't going to be how we get rid of it. Multiplication. That's what Caden said, right? So let's try this. 3 over 3 plus 2. What do you want to multiply? We don't want to get rid of 2. We want to get rid of the 3, right? So let's try multiplying by 3. When we do that, we get 9 over 3 plus 2, right?
Can we divide? It's 3 by 3.
They don't, because we have a 3 plus 2 here. The reason things cancel out, remember? When we do this, they cancel because we're doing 3 divided by 3. What's 3 divided by 3 plus 2? Well, it's 3 divided by 3 plus 2. And then we have to times it by the top. Right? Again, if you're not following, that's okay. I just want you to know that multiplication and subtraction aren't going to get the job done. They don't make those things go away. Because there's a plus sign down here. It complicates things, right? And again, we can't just add them together and make it 5 because we can't do that to these guys, right? So I kind of have to make a rule where you're not allowed to add those together, right? We want to get rid of the 3 and keep the 4. Yeah.
Could you divide the 3s and the 6s?
If you divide by 3, the same thing's going to happen with multiplication. It's just going to happen on the bottom. And it's going to change the 2 as well, right? So here's what we're going to do. This is hard because it's on the bottom. We're allowed to flip both, right? Again, if you do it to one side, it's fine, right? Well, actually, it's not. It's algebra. But if you do both, it's fine. It's algebra, right? So what if we did this? Oh, I flipped one, but not the other. I can't do that. That's child abuse. Can't have that on YouTube.
No, you'll get like straight up bad hammer.
All right. Now, this is a solvable problem. I'm going to do something, and I'm going to explain why it works. I think you'll see it better in reverse than forward, okay? Okay? Just trust me. Okay. This is the same as that. I think it's easier to see it in reverse. If I gave you 3 over 3 plus 2 over 3, do they have common denominators? Yeah, so we can add them up. 3/3 plus 2/3. How many thirds do I have? 5/3. Isn't that 5/3? 6/6 over 6/4. Whoops, sorry. Numbers are hard. 6/6 over 4/6. Do they have common denominators? Yes, they do. They're both 6. So how many 6 do I have? 10/6. Isn't that 10/6? So do you see how I didn't change the problem? I just made it look different. This is a legal move. You can do this when you have a single number on the bottom. Right? It says divide the 3 by 3, divide the 2 by 3, and then add them together. Divide the 6 by 6, divide the 4 by 6, and then add them together. That's legal. And again, you can check it because you can go backwards to it, right? 3/3 plus 2/3 is 5/3. That's 5/3. 6/6 plus 4/6 is 10/6. That's 10/6. I didn't change anything. I just made it look different. Life is all about perspective. Now, question. What's 3 divided by 3?
1.
What's 6 divided by 6? All right. Well, we got rid of the 3 and the 6 here. They're gone. We're just left with the 2 and the 4. Do you see that? We wanted to get rid of that 3 and that 6. And we are. We got rid of it. Now we have this, which kind of sucks, right? What can we do? What? How can we get rid of these guys? Because if we do, we win, right? Maybe you're not sure.
Subtract or
Can I subtract 1 from both sides?
yeah.
Right? As long as I do to both sides, I'm fine. And what's 1 minus 1?
0.
So it goes away. And what's 1 minus 1 over here? We did it.
How would you do this with
We got rid of the extra 3 and the extra 6. So now how do we do this? Right? How do we do this?
How are we going?
Right, here we go. Here we go. I told you you need a break. So we flipped it, right? Because having it on the bottom, really tough to deal with, right? Denominator's freaking weird. So let's just flip them. Okay, cool, right? I flipped them both. As long as I did both sides, I'm fine. Now, what we did next was we did this. Trust me, this is the same thing. You can check it by going backwards. Do they have a common denominator? Then I can put them all under the same denominator and add them up, right? Do they have a common denominator? Yeah, so I can put them all under the same thing and add them up. This is legal. We checked it with numbers, it works with numbers, it should work with letters. Now, what do you see?
Oh yes.
What's AC divided by AC? What's CD divided by CD? So we have this. Right. Great. Look what we did. We got rid of the extra AC and the extra CD. They're not there anymore, right? This is almost what we want. We wanted AB and AC together and BD and CD together. But we have the extra ones. How do we get rid of them? Subtract one from both sides. So we get this. Now, they wanted, where is it? They wanted AC on top and CD on top, right? And I got this. I wanted those on the top. What do I do? Flip them back, right?
Holy Jesus.
Do you want to know how long this file's going to take?
It's gonna be
Yeah,
multiple
like the
days.
exams.
All right, so
You sound like you're happy for
I
that.
am,
I'm not.
Dave,
We're not.
because you will become God when you graduate from this class,
Either that or I'll cry.
and that's what I make.
I'm gonna
I make
graduate.
gods.
I ain't gonna graduate from this class.
All right, check it out. We had this. We flipped them. We split them, right? Those are ones. They go away. I'll say it again. We flipped them. We split them. Those are ones. They go away. Okay? That was the algebra. We flipped them to get here, so we could split them. And then they became one, and ones go away because we can subtract one from each side, right? I know. It's not on the quiz tomorrow. Okay?
I don't know what's in like 24 hours of juice working night.
What did we do? Here's what we did. We created a bigger triangle. We proved this guy and this guy similar. And then we said that since they're similar, their parts should be proportional. We switched out XC for, or AC for, or AX for AB because they're the same, right? And we did segment addition postule to switch them out. So we went from XC to this and CB to that. Okay? Then we had a problem. How do we get rid of these two? We flipped them, separated. Things became one and went away. Take a second. I'm going to go through and talk about it. Okay? Here we go. We made a parallel. We extended this. These two angles were given to us to be congruent, right? Cap, alternate interior. These two sides are the same, so they're interchangeable. We proved that these two triangles are similar, so their parts are proportional. That's what got us this. We switched out these two sides, and we got this. AC over XC equals CD over CD. Well, there's X. We said XC is these two segments put together. So it's AC plus AX. And CD is CB, which is these two segments put together. CD plus BD. We said AX is the same thing as AD, right? Yeah, those are both congruent. We flipped them. Separated. Those both became one. We subtract one from both sides. We win. Oh, flip them back. But yeah. We win. It's not on the quiz tomorrow.
I thought the quiz was Thursday.
Sorry, it's not on the quiz Thursday. Good point. Not on the quiz review day
I
tomorrow.
was about to say.
Okay? There it is. This is as hard as you can get. That's it. That's it. It is hard, and it is. But the good news is it can't get any harder. And it won't be. In 2 weeks from now, you'll get this. 3 weeks ago, we took a quiz on side angle side congruency. Side, side, side. Right?
Now we're
And some of you guys are like,
sweating.
angle, angle, angle. Is that one we can use for congruence? This is hard. Right? And now you're like, what's wrong with me?
Dude, I'm
Right?
like shitting myself in this chair.
Now, some of you guys are still at that point. You need to come see me so you can catch up with the rest of these guys. It can happen, okay? 3 weeks from now, you're gonna be like, oh yeah, it flows. But it's gonna take 3 weeks. It's not, why I'm not quizzing you on it tomorrow, on Thursday. It's gonna take some time. The easier stuff we've done from this packet will be on that quiz. The harder stuff will be on it, the medium stuff will be on it next week, and the hardest stuff will be on it a week after that. This isn't going away. What we are embarking on next week is we're gonna talk about these theorems that we've already proven, right? That we went and did already in the packet. And we're gonna use those theorems, right? And we're gonna remember the proofs for those. So that's gonna come back. That's the medium stuff. The hard stuff like this one, right? That's gonna be on a quiz later. After we do that, we're gonna talk about circles. And here's how it's gonna work. No, here's how it's gonna work. You're gonna learn anything about circles, right? And there are gonna be triangles inside those circles. So you're gonna use the circles to figure out the stuff about the triangles, and then it'll be triangle stuff. You see what I'm saying? Once you get past the circle thing, it just becomes a triangle problem, which we've been doing all year. So you'll learn the new thing, which is the circle, and then the circle will go away and goes to the triangle problem. That's what we're doing, and it'll be done. That's the rest of the year. That's pretty much it.
What does a circle and a triangle?
All circles are triangles in disguise. Yes. It's gonna blow your freaking mind. We'll talk about area and perimeter and all that stuff too, but we're gonna prove the formulas. Why is the triangle area half based on side? How do we find the area of a trapezoid, right? We're gonna find those theorems. We're gonna find those proofs to figure out why the area is what it is.
Mr. Mack.
You guys can do it. It's just not gonna be something you can do right now. It will be in 3 weeks. Yeah.
This
My friends are gonna think I'm
this just kind of blows my mind.
This isn't on the quiz tomorrow. Or on Thursday.
Thursday.
Well,
That's as hard as it can get.
Jenna, I can tell your emotions are boiling over again. Just take it.
All right, she's talking to me. Shut up.
nothing. I need to get over it first.
No. You don't need to get over it. Your emotions are real. You're upset. That's okay. This is hard. It is hard, but that's why it's worth doing. Regular geometry class, and I've been in it. I graduated high school. I BS'd my way through all my math classes, not because I was smart, but because you didn't actually do no crap to get the good grade, right?
Yeah.
I don't want to do that in here because I think it's a waste of time. And I don't want to waste your time or mine. You will graduate as gods.
Yay.
You will. I'm going to make it happen, okay?
Jesus.
It's going to happen.
You go, guys.
Just give me time.
I swear you.
And I'll give you time too.
All right, okay.
If you